This is Professor Rudy, and this video is about how to solve a linear system of equations using MATLAB. So starting with a linear system of equations up here on the top left, this is the problem that I want to solve, and I want to go through how you would do this in MATLAB. So keep in mind this is a system of three equations with three unknowns, x1, x2, x3, but depending on your application that could be any number of things. Those could be different forces, accelerations, or whatever the unknowns are in your problem. But if you can get it into this mathematical structure, you can use this technique to solve. So for this type of equation, like I said, there's three equations and three unknowns, so we should be able to solve this. And if we want to use this technique, what we want to do is we want to get these equations into a matrix vector format. And so that's what's shown here. So what we want to do is represent these equations as a product of a matrix of known values times the unknown vector of variables equals whatever's left, taking those other terms over to the right hand side. So notice in that last equation we had to move that 6 over to the other side to fit into this format. But otherwise those are the coefficients of the unknown variables and then the constant terms. So once we get it into this format, if we could invert this matrix on the left and multiply both sides of the equation by that, we could get a closed form solution of x1, x2, and x3. So let's do that in MATLAB. So first, and I'm starting with a nice header here and the clear all statement. That's how we should start all of our script files. And now I'm going to get into what the code's going to do. So I want to define the matrix. So I'll call that A. And the way we define a matrix is by using square brackets and then entering in values row by row. So my first row is 5, minus 1, 1. I'm separating by spaces as I go across the row. You can also do commas. So I could do 0.5, comma 3, comma 2, comma 3. And then I'm using semicolons to get to the next row. So then for my last row, 1 minus 4, 7, and my square bracket. If I put a semicolon on that, that'll suppress the output so I won't see that matrix. So next I need to define the vector, and this is that vector of constants. So a lot of times you'll see lowercase b. And for these values, it's a column vector, so I want to do this as 4, semicolon 1, semicolon 6. That will define my vector as a 3 by 1. And actually, let's take these semicolons off, and let's run this and take a look at what these are. So our matrix A, we can double check that we entered this in correctly. This should match these values, and that looks correct. And then B should match these values, 4, 1, 6. That looks good. So then if we want to solve the linear system, one way to do this is using the inverse command. So we can calculate our vector x by taking the inverse of A, and that's the inv function, and then multiplying that inverse times the vector b. And we can run this and we should get a solution. So this should be the solution to those equations. And if we want to check that, we can take A times x and we should get b. And we do, 4, 1, 6. So that is one way to solve a linear system. We could also do this using the backslash operator. So you actually might have noticed here that the MATLAB is giving red underline here to inverse. Let's see what they're saying. They're saying that inverse of A times B can be slower and less accurate than A back divide B. So MATLAB has a more efficient way of doing this same calculation. So it will yell at you every time you try to do inverse of A times B. Not that there's anything wrong with it, but MATLAB thinks it can do it faster. So the other way to do this then is, as they said, it's A backslash B. And just make sure you're using the backslash, and this should give us the same result. So we have, this was using the inverse A times B, and this is using the back divide. Either will work, either one you can use, and that's the technique for solving a linear system in MATLAB.